Okay, in this video we're going to do a demo of the first two problems on the computer take-home exam for operating systems. This is in the usual place. There's an exam2 computer.txt that describes things. Okay, so I'm going to show it to you. You'll go to the usual place to get started. There's a start exam2 you can run. It'll copy it copies a fresh copy of xv6 into your directory. I've already done it here. So it'll create a directory for you, exam2, and then there will be a new copy of xv6 that you'll work on, and then the questions as well. And let me show you what my program does for the first. Actually, let's look at this exam2 computer first. Alright, so it has you build this up in phases. First phase, you're just going to have a program that forks. Parent and child print who they are. I'm the parent, I'm the child, and exit, and that's it. The second stage, put this kind of structure in. You're going to have your main program loop. You're going to get a line from the user. So you're going to printf a prompt, some kind of prompt, get a string from the user. If the string starts with fork, it's talking fork here, or you can just go straight to sleep, then you're going to do the fork. The child prints it's the child and exits. The parent prints it's the parent and continues. Okay, let me show you the final program. Okay, so there's the prompt, sleepy end. It's waiting for me to type. If you do a command it doesn't know, you you do nothing. The final program, you'll give it sleep in a number of seconds. It created a process, so this is the parent printing this, and then the child is going to print when it's ready to be done. So this is the child process. It did a sleep 10. Alright, so that's the next phase. For the phase B, you just have the parent keep going until it sees quit, and the child will just exit right away. Print that it's there and then exit. For the next phase, have the child sleep, but then you don't have to worry about figuring out what number they typed, parsing the string for that. Okay, and then make sure that they're typing sleep instead of fork if you're checking for fork. And then the last thing is to parse out what number they typed and make sure that it's something between 1 and 60. So if they type sleep 0, then it says it's setting the sleep amount to 1 because that's the minimum allowed. If they type sleep something like this, that's actually, that had an overflow. So if they do 100, then it resets it to 60. So this one it actually read as a negative number because of overflow. And since it read it as a negative number, it set it to 1. Alright, so that would be the first problem. This is just a regular program. And we'll say that's that. If you're going to work on that program, then you can go ahead and stop the video because I'm going to talk about the second one. And if you're waiting for the second one, then you know you can come back in at about 4 minutes. Okay, let me show you the second program. So I have my exam2 here. This is in xv6. We're going to make a new program called pwd. Let's look at the text over here. Okay, let me just run it first. Okay, here we are. If we ls, then there is a new program called pwd that's in there. And if I run pwd, it prints some things, and these correspond to the phases of completing it. So the first phase I asked for was just give me a PWD that just prints hello, and that's it. So you just have a new program. In order to do that, you have to modify the makefile to put PWD in the right places. If you search for primes, anywhere there's a primes, you need to do a similar thing for PWD. And then you would need a PWD program. So copy one of your existing programs. You could copy primes or something else. Alright, so phase A will just be print hello world. Let's take a look at phase B. Get the inode of the current directory and the inode number of the current directory, and so that is using stat with the file name dot. We can look up user.h are the things that we have access to. One of them is stat. So there's stat, and you give it a name of a file and a structure. So let me edit our exam2 file. Let's see, we're going down here. So phase A, you're going to have something like so we're going to need a struct stat, and then stat, if you do dot, then it's going to check the directory, current directory that you're in. Okay, you're going to do something like that to get the inode number and then print it. Let's go split screen here. Okay, so this B inode number of current directory is dot, inode of parent directory as well. Get the inode of the current directory and print it. Also for the parent directory. Stat with file name dot dot. Right. So you'll have something like this. Right. And then you'll have to go inside of that structure to see the C stat.h for the definition of the structure. Right, what are the different parts of that? Okay, so that's B, you're just printing the inodes. Okay, part C, I just want you to check the parent versus the current, and if it is the parent, if they're equal to each other, that happens when you're at the root of the file system, which we'll call slash. All right. So in the part C, I just want you to compare st parent and st, the inode numbers. If they're the same, then print that it's slash. That's it. Okay, part D is where the fun really begins. You need to get the name of the directory that you're in. So let me go over here. I'm going to make a directory called hello. And go into hello. Now I want to do pwd here to see what it says. I can't just type pwd like this because I'm not in the directory that has these files. That's in the root. So I can say /pwd. Okay, so if you don't get that, then stare at this again. I made a directory, I go into the directory, I try to run pwd, but pwd is not in the current directory. What's in the current directory? Nothing, because I just created it. Okay, so if I want to run programs that are back in the other directory, I need the full path. They're all in the top of the file system, so putting slash there makes it work. Alright, part D. I have figured out that the name of the directory I'm in is in hello. Okay, so the way to do that is mimicking what ls does. There's a program ls.c. if we look at ls.c, there's a main function. It passes in what directory or what file you want to do ls on, and then the ls function is here. ls opens the file or directory. Then it does fstat to get the inode number and type of file. And then, depending on what type it is, it does different things. If you do ls with a file, it's just going to print the information from the stat call. If it's a directory and you do ls, then it needs to list all the files. And this here is code to read the directory. So the directory actually is a file, and this is how to read it. Okay, so you basically want to copy paste this code and modify, and instead of just printing, you can copy paste and just run it, and then you should get a printout of the contents of the directory that you're at. But over here, I'm not trying to print out the contents of the directory. I want to just get my name. So if we did /ls ... then we get a printout of the contents of the directory one level higher. And we see in there inode 27. This is the inode number in the printout. And when I called pwd, the inode of the current directory is 27. So what I want is to modify this code in my program so that I find the inode 27, and that tells me that I'm at hello. So that's this printout here, part D. Okay, so that would be it. That you get the name of the current directory by looping through there. All right, now the last part is to get the whole path. Let's see. Okay, so I'll go into Bob. So now if I do /pwd, it starts by seeing that I'm in inode 28, and it finds out that that is Bob by doing /ls ... So in the level 1 higher, there's inode 28, which has name Bob. Alright, so that was from part D that you did that. But now I want to keep going up the chain. So the parent, I was in 28, that's Bob. The parent of that is 27, that's hello. In order to do that, I'm going to do the same thing as I did in D, but first I'm going to change my current directory. So I change the directory by there's a call chdir ... If I do that, and then I run this code again, then I should get the next level. And I want to keep doing this until I get to the case where the parent node, inode, and the current inode are the same. Okay, so it goes along like that at each level. It's printing the current inode and the parent until it gets to the end, and then put all those, so I got these names along the way, and then the last thing is to put them all together to say this is the full path of the current directory. Alright, and that's all in XV6. That is the end of that. Good luck.